Hello, here. How are you? Can you hear me?
Yes, sir, I can. I'm good. How about you?
I'm good. Thank you.
Assalamu alaikum. The
Assalamu alaikum. Say, let me correct my target. अच्छा वो worksheets make sure everyone does it on Google Classroom, ठीक है? अच्छा, 1 second. So let me just
Hello, sir.
hello, Nabila, how are you? अरे एक second. अच्छा again फिर से it's the same I mean there's just two boring equations left, ठीक है? Just two of them. वो करके we'll jump to formulas and equations. अच्छा ठीक है. Remember I've given you some work and there's going to be more work given on Google Classroom again. So there are two equations which are left that need to be done. And those two equations are that you have, so those two equations. If I go back, there were four bases, right? Where are bases? Bases. Yeah, there were four bases that we did. There was oxide, we made the equations for oxides, we made the equations for hydroxides, and we made the equations for carbonate as well. The last one that's left is the one with ammonia. That's fairly easy. These are all acid-base equations. So this is the fourth equation that we're going to do. Because that's the fourth one. So the fourth equation is that it's when ammonia reacts with an acid, it becomes an ammonium salt. Because it's ammonia plus acid. And what you get is an ammonium salt. Okay, that's the fourth equation. What so this happens. It's a base. Remember, it's a base. Ammonia is a base. We already discussed that. And it accepts the H that's coming from the acid. So you've got an ammonia, and I've got an acid, which is, let's say I've got HCl. The H will be accepted by ammonia. Ammonia is a base. And when it gets accepted by ammonia, ammonia becomes NH4 plus 1 because it accepts, remember, this ammonia over here. There's an H coming from the other side, so it accepts that and becomes NH4 plus 1. What is left? Cl is left. So that
chloride.
is the Cl group 7, and that's -1, right? So that's your salt. So it's basically ammonia plus HCl. So it's a very simple equation. So it's ammonia plus HCl, and it's going to become NH4. Cl, that's it. Okay, so that's one example. Let's take any other acid. It's going to be pretty much the same. Ammonia plus sulfuric acid. Careful. What's the formula of sulfuric acid? क्या होता है? Anyone, Ahmed, Zarar, Nabila, what's sulfuric acid?
H2SO4 होता है sir.
Okay, that's H2SO4. So again, the same thing. It's the acid will produce the H, and the ammonia is going to accept that H. The ammonia will accept the H, and it will become NH4 plus 1. And what's left is SO4. SO4 is what? SO4 is -2. Okay. Abhi don't just ignore the fact that there are two H's. The ammonia accepts the H and it becomes NH4 plus 1. While you do crisscross, it's going to become NH4 twice SO4. Crisscross, it's I mean the 2 over here will come over here, so it's going to become NH4 twice SO4. So I'm going to rewrite this equation. So it's what it's, and we're going to balance it. So it's ammonia plus H2SO4. And it's NH4 twice SO4. Ammonium sulfate. I just need to balance it. So there are two N's. So I need to balance the N's. So there should be two N's over here as well. So I'm going to double this. And that will pretty much balance it. I mean, the S is balanced, there's one S and there's one S. The oxygen is balanced, there are four oxygens and there are four oxygens. The difficult one was H because it was in three places. So if all the others are balanced, H is also going to be balanced. Kitne H's are? That's 6. And there are 2. So that's 8. NH4 twice means there are 8 H's. Okay? So I'm just going to do just one more. Okay, you've got ammonia plus nitric acid. So nitric acid is what? It's HNO3. Again, the same thing. Ammonia will accept the H and it will become ammonium. And NO3 is, what is the charge on NO3? That's -1. So rewrite this ammonia plus nitric acid, and this is going to be NH4 and NO3. Okay, one more. Is this clear to everyone? You clear?
Yes, sir.
So that's the fourth equation. Acha, there's one more equation, but that is not an acid-base equation. It's an equation for acids, but it's not an acid-base equation. So the fifth equation is an equation that happens when a metal reacts with an acid and it produces salt plus H2 gas. Okay, so it produces salt plus H2 gas, and so that's my fifth equation. Now in this equation, first thing is that it's not a redox equation, so it's not an acid base, and I'm going to explain why. So it's not an acid base reaction. Why is it not an acid-base reaction? Because acid-base hota hai when one produces an H plus 1, the other accepts the H plus 1, right? So that's what an acid-base reaction is, which is not going to happen over here. Okay, so instead it's a redox reaction. Well, we haven't done redox yet. Abhi Philal, you just remember that that's a redox reaction. This is a redox reaction. Let's say we also haven't done the reactivities yet. So what I'm going to suggest is that I'm just going to briefly talk about the reactivities, which is that when it comes to metals, not all metals are reactive. So some metals are very reactive. They react explosively, while others are not reactive. I mean, it's going to take them years or centuries to react. Okay, so you get a huge variety of reactions because metals, some of them are reactive and some of them are not very reactive. I said there's a reactivity series which we're going to do later on. Again, since it's linked with this, I'm going to write down the reactivity series. This is another thing that has to be remembered. So H, Cu, Hg, Ag, Au and P.
PPPB.
हाँ ठीक है, Pb वो पहले था. अच्छा, so
अच्छा.
so the trouble with this reaction is metal plus acid. First thing, it's not an acid-base reaction. ठीक है. No one acid bases someone loses H and the other one accepts the H. This is not going to happen there. It's a redox, जिसमें electrons gain or loss होते हैं, but since we haven't done redox, अभी फिलहाल just remember it's a redox reaction. Now, when it comes to the reactivity Cs, the the metals on the left side, they're very, very reactive. They're explosively reactive. ठीक है, so
तो
this side
सर
is
एक आंसर क्वेश्चन था आपसे.
hmm,
सर वो जो था एक रिएक्शन डिस्प्लेसमेंट रिएक्शन, वो आगे इसमें आता है सर, इसी चैप्टर में.
वो तो फिर reactivity Cs वाले चैप्टर में आता है.
हाँ, ठीक सही सर.
ठीक है. Nabila, वो the C is actually carbon. ठीक है. लेकिन अभी फिलहाल just ignore C and H. Remember, reactivity C is something that belongs to another chapter. The only thing you have to remember now is that in this, what we are doing right now is the metals on the left side are very reactive. Potassium explosively reacts sodium, explosively reacts calcium. जैसे जैसे right पे जाओगे ना, the reactivity decreases. So the ones on the extreme right are not very reactive. So the reactivity decreases. Now, within this, the first, see, let's look at group 1 and 2 basically, mostly group 1 and 2. They're going to explosively react. So these reactions are not safe. I mean, you should not be doing these reactions. ये जो reaction है, they will react explosively. So not suitable to perform or not safe to perform. ठीक है. The ones that are below H, specifically the ones below H are lead. Let's include lead as well. So these ones, they pretty much have no reactions with dilute acids. I mean, with very, very concentrated acid, they might react, but almost no reactions. A dilute acid is the one that you normally use. You don't normally use the highly concentrated acids. So almost no reactions with dilute acids. So it's kind of pointless to actually perform those reactions. I said the middle ones are the ones that will react normally. It's magnesium, aluminium, zinc, iron and tin. These are the ones that will have normal reactions. Okay, so these are the ones that are going to have normal reactions. So will react normally. Safe to perform. They're going to have moderate speed. So it's not going to take them years to react. They will react within like 5 minutes. The reaction will be over. Now, one way to remember this, I mean, so the whole point of doing all of this is when you have this metal plus acid reaction, right? The one that's written above, you need to know which metals are suitable for this reaction. So these are not suitable. Their reactions are too slow or they're not going to happen. These are not suitable because these reactions, I mean, their reactions are going to be explosive. I mean, you're going to have a violent explosions. The middle ones are the ones that are going to normally react. Now, one way to remember the middle ones is the ones that have a decent reaction is that you remember MASIT. Okay, it's magnesium, aluminium, zinc, iron, and tin. SN is tin. Okay, so make sure you remember. Remember करने के लिए, just to remember this. Do remember that MASIT metals have these normal reactions. So make sure you keep this in mind. MASIT is something, I mean, it's just a mnemonic. You just have to keep this in mind. Magnesium, aluminium, zinc, iron, and tin. These are the ones that will have decent reactions. The other ones are not going to have decent reactions. So again, metal plus acid, salt plus H2. So there's this additional stuff that you have to remember. Okay, which metals are going to normally react. So is this clear? I mean, before we make the equation, is the first part clear? Which metals are we talking about? Is that clear?
Yes, sir.
Okay, Nabila, is this clear? Everyone else? This is the okay. Baki, we'll study reactor series when we discuss that's something that is going to be done later on. So we're going to make this equation. First thing, remember this is not an acid-base equation. So I'm going to make equations for MASIT metals. Let's start with magnesium. Magnesium with an acid. So for example, hydrochloric acid, that's HCl. So what happens is the Mg is going to come in. It's also called a displacement reaction. The Mg is going to come in and it's going to knock out the H. The H is going to get knocked out. And when the H gets knocked out, it's going to produce H2 gas. And Mg is going to replace the H. So it's going to be Mg and Cl. You have to do crisscross again, which is that Mg is in group 2, so it has a charge of +2, and Cl is group 7, so it has a charge of -1. So the formula would be, if you do crisscross, it's going to be MgCl2. Okay, is this clear?
Yes, sir.
तो
चलो
simple reaction है,
बैलेंस तो नहीं है
वो कर लेते हैं बाद में. Mg plus, let's say, phosphoric acid, H3PO4. So again, same thing. Mg is going to come in. It's going to knock out the H, and that will produce H2 gas. Remember, I mean, again, remember, balancing is something that's going to be done later on. When the H gets knocked out, it's going to produce H2 gas. And Mg is going to take its place. So it's going to be Mg and PO4. And you're going to make the formula again. Mg is group 2, so it's +2. What was the charge on PO4? क्या था किसी को याद है PO4? What is the charge on PO4?
-3
Yeah, that's -3. So it's going to be Mg3. And PO4 would be twice. Okay. We can think of another metal. Let's think of MASIT. M is magnesium, A is aluminium. So we can do a reaction of aluminium with sulfuric acid, which is H2SO4. Al is going to come in. It's going to knock out the H. The H is gone. And so it's going to become AlSO4. I mean, the H is going to be knocked out and it will produce H2 gas. Al is group 3, so it's +3. SO4 is -2. So if you do crisscross, it's going to be Al2. And SO4 will become 3. Okay, is that clear?
Yes, sir.
And so then we can balance it, right? If I try to balance it, like the first equation, Mg is balanced already. Easy ones. वो मैं एक second. That's remember, Nabila, I told you that balance. I mean, you make the formulas first. I mean, you're going to knock out the H. I told you that the H becomes H2. TK, hydrogen gas is produced. Once the formulas are made, then you start balancing it. So where does the second H come from, right? So the second H, you need to balance it. I mean, H2 gas has 2 H's, right? So how do you balance it? It's supposed to be 2 H's over here. So I'm going to multiply it by, I'm going to make it 2 HCl's, okay? And now the equation is balanced. I mean, there were two CLs as well. I got one CL, but now it's two CLs. Okay. So remember, so keep that in mind. Okay. Like when over here AL knocked out the H. बल्कि इस वाले में Mg knocked out the H will produce H2 gas. It's not balanced. I mean, there are three H's and there are two H's. That's not balanced. But make sure it's going to produce H2 gas. Okay. You're going to do the balancing at the end. When the Mg knocks out the H, the Mg comes in and takes its place. And if you do crisscross, it's going to be Mg3PO4 twice. So again, that's not balanced as well because there are three Mgs and there's only one Mg over here. Okay. But the priority is you make the formulas first and then you balance it. So second equation, if I want to balance it, to balance the easy ones, 3 mgs. There's only one mg, right? I'm going to make it 3 mgs, right? So mg is done, easy ones. That appears in two places. You got three h's and you got two h's. How do you balance this? 3 h's on this side, 2 h's on this side. You multiply both of them with a number, right? So you can multiply this by 2 and this one by 3. So the h over here will become 6 and the h over here will become 6 as well. Again, balance the easy ones. Oxen is in two places, so we balance that. There are 8 oxens and there are 4 oxens, but it's being multiplied by 2, so that's also 8 oxens. So P is also balanced. PO4 twice, that means 2 P's. PO4 has 1 P and there are 2 of them, so that's also 2 P's. Or you see that I'm going to do the last one, which is AL, 2 ALs. SO4 thrice, so I'm going to make it 3 over here because S over here is thrice. So I have to make it thrice. H will become 6. So I need to have 6 H's on that side as well. Okay, is this clear?
Yes, sir.
Okay, and the reason why this is not an acid-base equation, because an acid-base equation is that the acid produces H plus 1. But no one is accepting the H, right? But it just turns into H2 gas. So that means it's not an acid base. An acid base equation was, the previous equations were all acid base. Like ammonia, the acid produced an H, right? And the base accepted the H, right? That's an acid base equation. This is not. I mean, if they ask you why this is not an acid base equation, well, the acid did produce the H ions, but no one accepted it, right? So it's not an acid base equation. एक और कर लेते हैं. We'll just do one more. Like if I Mazet, right? Let's do zinc with nitric acid. As I told you, zinc is a transition. It's in the transition metal block, but they will never tell you what the charge is. I told you what the charge of zinc is.
+2.
+2. Okay, so zinc was always +2. So zinc is going to knock out the H. And zinc will become +2. What is nitrate? NO3. NO3. What is the charge on NO3?
Sir, -1.
Okay, so it's going to be Zn. And NO3 twice, and the H is going to get knocked out, so it's going to be H2 gas. And you just have to balance it. So you have 2 H's on the right side, so I'm going to multiply this by 2. So I got 2 H's over here as well. And the rest of the equation looks balanced. There are 2 N's. NO3 twice, that's also 2 N's. 6 oxygens, 3 oxygens, but that's multiplied by 2, that's also 6 oxygens, right? So this equation is now balanced. Okay. So 5 equations. There's one more which we'll do at the end of the chapter. That's going to make it 6 equations. There are actually 2 more equations, but we'll talk about those equations when we come to them. But sticking to these 5 equations now, the next thing is, so remember, things are going to be difficult. You have to remember sulfate, nitrate. You need to remember all the charges. You need to know the names of the acids. You need to know the formulas of the acids. You need to know how to make the whole equation. You need to know how to balance the equation, right? Now, there's some additional stuff, which is you also need to know the solubility table, which is which of these compounds are soluble and which of the compounds are not soluble. So not all salts are really soluble. And when it comes to solubility, like you've got marble, which is calcium carbonate. That's not soluble. But you've got NaCl, which is very, very soluble. And when we were doing ionic compounds, I told you what does it mean when something is soluble? That means that it will
Completely dissociate.
Okay, so when NaCl dissolves, you had you had an NaCl crystal, right? You had Na plus one and Cl minus one ions. So you had a crystal where all the ions were sticking together. Positive ions, negative ions attracted to positive ions. So you had Na plus one ions and you had Cl minus one ions, right? When you stirred them in water with a spoon, all the ions dissociated, they scattered, right? That's what solubility is. That's what happens to NaCl when you mix it in water. Why does it disappear? Because the ions, they dissociate. They're all separate now and they're all floating around, completely separate. And they're all, so the positive ion is now very far from the negative ion, and the negative ions are very far away from the positive ions. And there are billions of water molecules that are in between. So it's very hard for them to form the crystal back again. So that's what happens. It dissociates. So ionic compounds dissociate when they dissolve in aqueous solutions. And form aqueous. I said the next season, that's also something that you have to remember always. It's also something very important and very hard to remember. So make sure you keep that. I mean, you note it down at the end of your copy, so you know you have a reference place where you can always. You have to. A lot of times in chemistry, you would have to go back and have a look at the solubility table because you're going to forget it anyways. So, but don't worry, okay, over time you got 1 year to remember it. If you keep on using the solubility table, you'll eventually remember it. Because even right now you've got a lot of time to remember this. So ionic compounds dissociate. One thing was that if the attraction between the ions is very strong, so in that case it will not dissociate, it will not dissolve. Marble is one example. Marble ke andar the ions, marble is like really strong. The ions are very strongly attracted to each other, which is why it's hard or difficult for it to dissociate. NaCl, the ionic lattice is probably weak. The positive and negative ions don't attract each other very strongly. So when you stir it with a spoon, the ions all of them they get scattered, right? So some ionic lattices are weak and they are easier to dissolve, and other ionic lattices they tend to be like really really strong. So coming back to this point and coming back to the solubility table, there's certain rules. Let me continue. One second. There are certain rules, and we're going to talk about those rules. So the rules for solubility. Now, the first rule is rule number one. All of these compounds are soluble. All group 1, NO3 minus 1, any compound that has NO3 minus 1. So any compound that's got NO3 minus 1, NH4 plus 1 compounds, they're all soluble. Any acid, by acid I mean anything that's got H plus 1 in it and is capable of releasing H plus 1 like HNO3, H2SO4, H3PO4. All of these compounds And then we put acids in bracket. H+1 means that's definitely an acid. So all of these compounds are soluble. They're all going to dissolve. Okay, without exception. I mean, so for example, if I have NaCl, that is soluble because it's a group 1 compound. If I have K2, K3PO4, that will also dissolve because K is group 1, right? If I have aluminum nitrate, right, anything that's got NO3 in it, that is also soluble. If I have H3PO4, it's got H in it, so it's also soluble. So any one of these, if it's got group 1, if it's got NO3 minus 1, if it's got NH4 plus 1, if it's an acid, all of them are going to be soluble. So they're all going to be written as aqueous substances. They're going to mix in water. Okay, is this clear? The first rule.
Yes, sir.
That's the second rule. The second rule is that all sulfates are, so anything that's got SO4 minus 2 in it. Well, these are mostly soluble. So they tend to be very soluble. Except there are lots which are not soluble. So there are some exceptions. So most of them they are soluble, but you got plenty which are not soluble. Except you got silver sulfate, that's not soluble. I mean, you dissolve it in water, it doesn't dissolve. You've got lead sulfate, that is also not soluble, it's a solid. You've got barium sulfate, that is also not soluble. You've got strontium sulfate, that also is not soluble. And there is calcium sulfate, which is partially or very slightly soluble. I mean, you can classify it as insoluble, but it slightly dissolves. So there are plenty of exceptions to this. So plenty of exceptions. But most other sulfates, you got sodium sulfate, iron sulfate, any other metal like potassium sulfate, copper sulfate, they're all soluble. Okay, so that's for sulfates.
सर लास्ट वाला Ca है
CaSO4.
yes वैसे ये partially soluble है या सारे partially soluble
नहीं वो first except का मतलब है कि not soluble. ठीक है मैं इधर लिख देता हूँ these are not soluble. These are the ones that are the rest are soluble. So the rest are soluble. These are the ones that are not soluble. I said next one, point number 3. Achha, all chlorides, halides basically. Halides are group 7, right? Group 7 ions are, group 7 is halogens. And their ions मैंने कहा था when we do elements and the ions, the negative ions are, their name ends with ide. Chlorine becomes chloride, bromine becomes bromide. So halides, so all halides are soluble. Except, I mean, this one has exception as well. There are two that are not soluble. Except silver halide and lead halide. Okay, where X, it could be Cl or it could be Br or it could be I. Okay, so it could be AgCl, it could be AgBr, it could be AgI as well. Okay, so except for silver and lead, all the other halides, NaCl that's soluble, NaBr that's soluble, KBr that's soluble, So all the others are soluble, but not AgCl
Yeah,
or PBs.
by this you mean the compounds of halide, right?
हाँ ऐड कर लो compounds, ठीक है? वो sulfates में भी I'm talking about sulfate compounds, ठीक है? Remember, it's going to be a compound because negative ions, they don't exist alone. There's probably going to be a positive ion attached to them. Okay. So FeCl3 iron chloride, that is soluble. Copper chloride, that is soluble. So all chlorides, NaCl, that is soluble. So all of them are soluble, except if you have AgCl, that is not soluble. You've got PbCl2, that is not soluble. You've got PbBr2, that is also not soluble. Okay, Baki, the rest, all of them are soluble. Okay, is this clear?
Yes, sir.
Remember, this is the hardest to remember. Okay, so make sure you copy एक page पे you note this down because a lot of times you're going to forget this. So it's really difficult to remember all of this. But it is something that's really important, which is why it's if you have it right in front of you, someplace easily reference because it's going to be used a lot in chemistry. That's a concept point, and that's third or fourth, I think. So we're done with, now we're going to talk about carbonates and phosphates. So all carbonates and phosphate compounds here they're mostly not soluble. So this time it's the opposite. So most of the carbonates and phosphates that you see, they're not soluble except the ones that we told were always soluble, except group 1. NH4 plus 1 carbonates and phosphates, and your acids, right? H plus 1, the ones that have H plus 1 in them. So as an example, if I have sodium carbonate, that is soluble because it's a group 1 carbonate. I have potassium carbonate, that is soluble. I have ammonium phosphate, that is also soluble. So these are soluble. But apart from
The
group 1 and
phosphoric acid will be also soluble, right?
because it has H plus 1, ठीक है, acids are soluble. Apart from group 1 and NH4 plus 1 and acids, the rest are all insoluble. Okay, so these are all soluble. Okay, example here. Well, if you talk about iron carbonate, that is not soluble. If you talk about calcium carbonate, that's group 2, right? So that's not soluble. You talk about aluminum carbonate, that's group 3, that is not soluble. Okay, so the rest of the carbonates and phosphates are not soluble. Okay, clear?
Yes, sir.
So इसी practice करेंगे. फिर we've got then we've got कौन रह गया? Oxides and hydroxides. So oxides, the ones that have O minus 2 ions in them, and hydroxides, which is OH minus 1. So oxides and hydroxides. These are also mostly insoluble. So most of them are insoluble. Again, except one is soluble in group 1 and NH4 plus 1, right? Uh, Acids don't have OH ions or oxides, so we can ignore that. Group 1 NH4 plus 1 are always soluble. And those lower down in group 2, in your entire pure table, like if you have your pure table in front of you, group 1 is soluble, the first column. All the oxides and hydroxides of group 1 are soluble. Group 2 mein the bottom ones are soluble, the ones at the bottom, right? And the rest of the pure table, they're all insoluble, right? So for oxides and hydroxides, all of them are insoluble except group 1 and those lower down in group 2, and NH4 plus 1 as well. I said those lower down in group 2, that is like group 2 is magnesium hydroxide, and you've got calcium hydroxide, and you've got strontium hydroxide, and you've got barium hydroxide. The first one is completely insoluble. The second one, it's partially soluble. It doesn't really dissolve much, but it slightly dissolves. And lower down in group 2, these two are soluble. Okay, so group 1, all group 1 oxides and hydroxides are soluble. Group 2, only the bottom ones, right? The bottom ones. So group 2 is right at the bottom. These are the ones that are soluble. NH4 plus 1 is soluble, but the rest of the pure table, they're all oxides and hydroxides are insoluble. Is this clear?
Yes, sir.
Just that's my solubility table. That's the rules for solubility. So all group 1 nitrates, all sulfates are soluble except for there's some exceptions that are not soluble. All chlorides, bromides, iodides are soluble except there are some exceptions. All carbonates and phosphates are mostly not soluble. Again, exceptions. Group 1 are soluble, NH4 plus 1 are soluble. And oxides and hydroxides. And Ismina, when you talk about oxides and hydroxides, I'll just add one more thing, which is when oxides are dissolved in water, they turn into hydroxides. So in aqueous state, you don't really have oxides. Let me just, like you've got calcium oxide. Calcium is +2, oxygen is -2. If you dissolve it in water, it becomes a hydroxide. Because instead of an oxide, it becomes a hydroxide. When you get rid of the water, it turns back into an oxide. So remember, oxides and hydroxides are kind of the same thing. It's just that the presence of water will turn an oxide into a hydroxide. O minus 2 will turn into OH minus 1. You remove the water, it will turn back into an oxide. But anyway, that's for later. Okay, right now, just copy this. I'm going to send some notes as well. All the details are given. Uh, Make sure this table is very important. So have this written somewhere right in front of you. Because we will be referring to this. We would practice this a little bit so we know which compounds. But okay, let's practice it slightly. Because I've got an acid over here. Is it soluble or insoluble? What did we learn about acids?
Soluble, sir.
Okay, acids are all soluble. That was the first line. The first line was that all group 1, NO3 minus 1, NH4 plus 1, and all acids, they're all soluble. Okay, NO3 minus 1 compounds are also all soluble. So what is the state of zinc nitrate? Okay, it's got NO3 minus
Soluble होगा.
it's got NO3 minus 1, right? So that means this will also be soluble. Anything that's got NO3 minus 1 is soluble. Anything that's an acid that's or has H plus 1, that is soluble. I said this is H2 gas, but hopefully everyone knows this one's a gas, okay? And hopefully everyone knows zinc is a metal. It's a grayish metal, and that's a
Solid.
metal is a solid, okay? So बस ये ऊपर एक आखिरी कर दें, then we can Sulfuric acid, that's aqueous, right? It's an acid, right? Aluminium is a metal, that's a solid. What is aluminium sulfate? Now, what I'm going to do is I'm going to go and have a look at SO4 because there was a, yeah, we talked about sulfates, right? So sulfates are mostly what? They are mostly soluble. Except for these are insoluble, right? So aluminium sulfate, so that means it's mostly soluble, right? Is that clear? Okay, apart from these 4, 5, these 4, 5 were the only ones that were not soluble. The rest of the sulfates, they were all soluble. So when it comes to aluminium sulfate, it's going to be soluble. Okay, all sulfates are soluble except for those 4, 5 sulfates. NH2 is a gas. Okay. So ये फिर ना we'll practice this more in the next class then. ठीक है?
अल्लाह हाफिज सर
चलो ठीक है. Okay, everyone.
Sir.
ठीक है, अल्लाह हाफिज.